Hi everybody. Today we're going to talk about resolving a vector into its components. So as a warm-up bell ringer here, I want you guys to complete 1, 2, and 3 on your own. Just pause the video for a second. You need to, and just complete those just to test where you're at with our vector symbolically doing addition, subtraction, and scalar multiplication. Now, a couple things to talk about before we move on with the rest of activity at 32. Overall, this looked really good, the review stuff. The main things that we were having issues on, letter B on number 16 was actually asking you to graph 16 number 4 because they wanted you to graph the one that would have a petal length of 4. And a reminder, this coefficient out front here of 4 is going to determine your petal length. So they wanted you to graph 16, 4 for part B here, just as an FYI. The other big thing that I wanted to chat with you about before we move forward is a lot of you in your explanations were talking about how for number 20, the vectors Q and N are the equal vectors, which is true. But obviously because of the slope, you're not fully wrong, right? They do have the same slope if we're making them lines, but really we're talking about with vectors, in order for them to be completely equal, they have to have the same component form. So P and Q would be equal because they both have a component form of 2, -3, not that their slope necessarily was the same of -3/2. So just keep that in mind when we're talking about vectors. Otherwise, everything really looked good there. So as we move on to today's stuff, we have, again, we're going to talk a lot about finding the directional angle of a vector, resolving it into its components, and then again, still kind of sketching that stuff on the coordinate plane. So if we go back to this robotic arm example that we've talked about before, if we were going to talk about the overall magnitude of u plus v, this vector here that was sketched in before, we know that in order to find the magnitude, we need to use a squared plus b squared. So to get that magnitude of u plus v, and again, that's going to be represented with what usually to us is our absolute value bar, you take the square root of a squared plus b squared, and in this case, you're going to get approximately 18.2 as your final answer here for the magnitude. And then when we talk about the trigonometry to find your theta measure, notice this is a quadrant 1 value, so we're going to want theta to be a quadrant 1 value, and then it's b over a, or, opposite over adjacent, y over x, but in this case, b over a, so tan inverse of 3 over 18. If you type that in the calculator, you get approximately 9.5 or 9.462, if we're going to go a couple decimal places, degrees, which again is a quadrant 1 value, so we're good to go there. So tiny angle, right? But moving forward, we need to take a little bit more care because not everything's going to be quadrant 1. Not all of our vectors are going to come from standard position, things like that. So we need to be careful there. So if we look at example 3a, all goes back to thinking about this as a right triangle, and inside here, as tiny as possible, we have that theta measure as our angle, and it's a right triangle. So when we think magnitude, again, magnitude is kind of the length of that vector. So we're thinking kind of, in this case, the length of the hypotenuse of this right triangle. So again, with our magnitude, it's going to be the square root of a squared plus b squared. But we got to be careful here. Notice the scale on our graph, we're going up by 2's. So when we moved to the left, we really moved to the left 4 units because our scale was 2, and we moved up 8. So our component form here, -4, 8, and that's what we would use as a squared and b squared. We're using, again, a and b from our component form, how much we moved. Right, so we get about the square root of 80, or 4 square root 5, or approximately 8.9, however you choose to write all that. Directionally, again, we need to be careful because directionally, this is in quadrant 2. So we know our angle measure needs to come from quadrant 2. So as we look for tan inverse to help us find this angle measure, opposite over adjacent, b over a is a over -4. And as we type that in, tan inverse of 8 divided by -4. Notice that's quadrant 4, but we're in quadrant 2, so we need to add 180 degrees to that. So really, we're at 116.6 degrees. So just gonna be careful on that. All right, so there's your magnitude, there's your direction. Now again, we have to be careful because we're going off of component form here. So if we draw in this triangle here, actually let's draw this in so that we went to the left and down, right? So we're gonna have to draw it in like this. This officially, to us, if we're going to the left and down, and notice we're going to the left 6 units and down 6 units, would to us look like a quadrant 3. If I didn't, give you any description other than we went to the left and down, you would say, oh, that's quadrant 3. So again, keep that in mind. You want an angle measure eventually that is coming from quadrant 3, and our component form is -6 and -6 for A and B. So again, what we need to be careful of here is finding the direction, because the magnitude again is going to be pretty straightforward. As long as you type this in correctly in the calculator using parentheses around those negatives, you're going to get the square root of 72 or 6 square root 2 or just approximately 8.5 if we're rounding that way. While directionally, again, you need to be careful because in this case, theta is going to equal tan inverse of -6 over -6, which, if we're not careful in our calculators, is going to come out to be the wrong quadrant. So again, -6 divided by -6. This is quadrant 1. We know we need to be in quadrant 3. So really our theta is at 225. Okay, so just some things to be careful of there. Right. Now, on your own here, take a moment to draw and find the magnitude and direction of C and D. Now, a couple things. Again, take a moment to draw this. You're going to the right 12, down 4. So think about what quadrant am I in? What would my theta measure have to be? As well as in letter D, think about the change here. When you're going from tail to head, what would your component form be? Right? How much did you have to move? That would be your A and your B values. So take a moment to make sure you try that on your own. All right, now to check yourself, what you should have gotten here is that your magnitude, if you did this correctly, is that the magnitude is going to end up being about 12.6. I'm going to use the square root of a squared plus b squared. And then our directional value, our theta here, is going to be, you have two options here. This one's your calculator is going to give you an output value of -18.4 degrees. That's okay, because that is officially quadrant 4. Or you could do 341.6 degrees if you add 360 to that. So just keep that in mind. Now for letter D, as you started solving this, notice to go from tail to head, you had to move 6 units to the right and you had to move down 11 units. So really your A and your B values you were using were 6 and -11. So be careful on that to make sure that you were using the appropriate values. And again, you should have had for your magnitude then, if you were using the correct A and B values, about 12.53, and directionally comes out to be -61.4 degrees, or again, if you're adding 360, because this is also a quadrant 4 value, right? 6 down 11, could have added 360 to that, you would have got about 298.6 degrees. Okay. So that's this beginning part here. And I'll pause it there, but this is basically just kind of the beginning of finding the magnitude and direction.